Welcome to Lab 2. This is the second lab in Physics 1107. And in this one, we're going to take what we did last week and we're going to extend it a bit. So we're going to start talking about what happens if the velocity is not constant and how do we deal with that. This is known as constant acceleration, and we will be doing an experiment where we take last week's experiment and we add constant acceleration to it. So how does the math on all this thing work out? Well, last week we talked about constant velocity motion, and we found this equation applied. If you had a constant velocity, you could take that velocity, multiply by the time that goes by, and you get the displacement. But what if v changes? What happens then? Well, there are many ways v can change. The easiest way is if it changes in a constant kind of fashion. This is called constant acceleration. And if that's true, then the change in the velocity is proportional to the time that goes by, and it is proportional by a constant known as a for acceleration. Now, in real life, people talk about acceleration. They usually mean making their car go faster. In the physics world, what we're talking about with acceleration is any change in velocity. It can get faster, it can get slower. Later on, we'll find out it can go around in circles. All this stuff is covered under acceleration in the physics world. If you do have a constant acceleration, then we can take this equation and we can invert it and get this one. And what this equation is telling us is that the velocity at any time is whatever the velocity is at t equals 0 plus the acceleration times the time that's gone by since then. This 0 on here is a subscript. We use those in physics a lot. Subscripts are how we tell one velocity from another. And sometimes the subscripts get really out of hand, but they're still pretty easy at this point. But anyway, that's what that means. This is just one velocity when t equals 0, and this is the velocity at any other time. Okay, so that's the velocity formula we have for constant acceleration. While this thing is accelerating, it's also moving. It's going through some sort of displacement, and there's a formula for that. You can find this thing derived in your book if you want to look at that. Here's the final formula you get. This is a formula for the position at any time t. It's v0 times the time that goes by. This v0 is the same as that one. This is the velocity it has when t equals 0, plus this new term. And this new term is 1/2 times the acceleration times t squared. So the idea with this one is that the acceleration makes it go faster and faster as time goes by. If you have something falling, it accelerates at a constant rate. And if you look at it as a function of time, every second it falls further than it did the second before. So if a lot of time goes by, it falls a very big distance indeed. It's moving very, very quickly. We'll see how this adds to our function when we get to the experiment. What we're trying to get to with our experiment today is another spreadsheet. And this one will have a column for position. It will have a column for time. We will take the change in position, divide by the change in time, and get the velocity out of a formula. And then by taking changes in velocity, so looking at how this one compares to that one, and dividing by time, we will get the acceleration. Hopefully we will get the same acceleration all the time. We'll see how well that works out. Now it's time to do the actual lab. So we have our equipment all set up. Most of this equipment is the same stuff you used in Lab 1. The only difference is that we have our glass thing, but we have a prop under one end of it. This is just a book. The idea is to make this thing slanted a little bit. You want something like 2 or 3 degrees, so a very, very gentle slope. We have one hardcover book under one end. This is about a 2-foot long slant. That's enough. Don't go much more than that or things start getting out of control. We also have on this glass the same piece of tape from last week with positions marked off. This is the same as last week. The positions are every 4 inches, which is about 10 centimeters. We have the car with the pencil taped to it, and we have a bag of washers to give some more weight to the car. Just put those in the passenger compartment. To give us something to analyze, we need some kind of noise for Audacity to work with. So we take these little echo clips that we were using last week, same things, and put them upright at each one of the marks on the tape, so that when the car goes by, it will get knocked over and make a little bang. Now, these things do tend to want to tip over on their own. Good for them. Okay, we'll put one of those at each one of our marks. Now we're ready to go. We've got the microphone listening to this whole thing. This is our Physics 1107 mic. It just looks like an alien. And I'm about to start up Audacity by clicking on the big red button. Audacity is now taking data. I'll put my little car here. It will roll down the hill by itself and knock over the clips as it goes. And here we go. Audacity is working. And I got 1, 2, 3, 4, 5 good bangs. Good data. We're all set to go. Let me stop Audacity. The next step is to go back and analyze that data. Okay, now we have to analyze this data we took. And to do that, we're going to put it in a spreadsheet like we did last week. I'm going to be using Google Sheets, which is a nice, easy one. So what do we have? We know where the marks are in inches. We made one of those every 4 inches. So we're going to convert those to centimeters with this formula. You just multiply them by 2.54 and you get centimeters. We'll also be getting the times at which different things happened. We'll get those from Audacity by looking at the numbers in the audio recording. Once we have those, we can use those to calculate the velocity at each step by using a formula. We'll take the change in x, divide by the change in time. That will give us the velocity at each step as it goes by each clip. And then using those, we'll go one step beyond and calculate what the acceleration is as it rolls down the hill. This is the change in velocity divided by the change in time. So we're going to do all that with the spreadsheet, and this is how we do it. We start out by opening up a new spreadsheet, and then we have to make the columns. X in inches, X in centimeters, the time, velocity, and then one after that will be acceleration for each spot. So I've got these things all made up. Now let's put in the data we have. Each clip was spaced 4 inches along from the one before it. And I had 5 clips on my thing. If you only have 4, then you should only make 4 rows here. X centimeters we can do with a formula. And so you type in equals, you grab the one you want to multiply, and then put in a star and 2.54. That will convert from inches to centimeters. And to repeat that, you just drag it on down. Okay, so now I've got all my x's in centimeters. The next thing to get are the times. And to do that, we have to go back to Audacity and look at our data. Here it is, and we get a good look at the data. If you want to hear what's going on in Audacity, you can do that by getting the cursor, dragging it over the part you want to listen to, and clicking on the little arrow, and that plays the sound it has recorded. So you can use that to make sure you're zooming in on the right clicks. If you want to zoom things up and make your recording a little easier to deal with, you can just use the zoom button. That will zoom it on up and you can get a better look. The clicks are actually pretty clear in here. This first one is right here. The second one is here. Third one is here. Fourth is here. And the last one's down here. And if you look at this, you can see that the time gap between the first and second is quite a bit longer than the one at the end. That indicates that this cart really is speeding up and things really were working right. Okay, now we have to get some times off of this. So to do that, I'm going to blow it up even more. There we go. Here's the first click, and we'll get the time on that one. The time here, we put this into hours and milliseconds at the bottom, that's right. And the time is 42.400 seconds. So we put that into our spreadsheet, put 42.400 seconds. We go back to Audacity for the next one. Okay, now we've got our time numbers entered, and now it's time to calculate the velocity. And to do that, we're going to use this formula. Velocity is the change in x divided by the change in time. The change in x is the x in a cell minus the x of the cell before it. The change in time is the t in a cell minus the t before it. And we will do that with a formula here in this spreadsheet. If you're paying close attention, you notice that means we can't do the first cell because we don't have a time before it. So we have nothing to subtract. But that's okay. We'll just leave that one out. So here we go. We're now in the V column, the second cell down, and we're going to put in our formula. And to do that, that's just equals, open up a paren. I want the change in x, so I want that one minus the one above it, and I want that in parentheses, and I want that divided by more parentheses, the change in time, which is this one, minus the one above it. And there we go. Boom. So we get that. Now to put the same formula in these other columns, I just grab it and drag it on down, and I get this. And if you look at these numbers, you can see they're sort of 21, 28, 35, 40. The velocity is definitely going up as time goes by. That's exactly what we expect. It is accelerating. As time goes by, it moves faster and faster and faster. The last column is the acceleration column. And to do this, we're going to do the same kind of trick as we did for velocity. We're going to take the change in velocity, that means the velocity in a cell minus the velocity above it, divided by the time in a row minus the time above it, and call that the acceleration. So let's see what we get that. And again, we can't do the first cell because we don't have a velocity before. We can't even do the second row because we don't have a velocity for the one above that. So we have to start in the third, and we enter in our formula here. And it's equals open paren. I want the change in velocity, so I want this one minus the one above, parentheses, and I take a divide, more parentheses, divided by the change in time, which is that minus the one above it there. And we hit return, that puts it in there. There's our acceleration between these two rows. To find more of these, I drag it on down, and I get this. So the accelerations I have are 18 for the first one, then 25 and 22. They weren't quite perfect, but that's to be expected. Friction is doing stuff to us in these experiments. So is the fact that knocking over the clips takes a little bit of speed off the car. But all in all, that was pretty good. And now it's your turn. You get to go out and set it up yourself. Give it a try. Good luck, and send me the results.